So I'm Jordi Puig-Suari, and there's a couple of things I want to say about my background besides CubeSats and all that. I was born in Barcelona, Spain, and when I decided I wanted to do aerospace, that was the beginning of many. Oh no, that you cannot do that. And basically, I found myself in a place where there was no aerospace industry, and I had to go somewhere else. And actually, to me, that's one of the things that I'm most proud of with CubeSat is that a lot of the people that I've seen in the conversation today come from places that are not traditional space powerhouses, but CubeSat opened it up, and now we have a bunch of different countries and people that have been able to do space that couldn't before. So that's very personal to me because I was in that boat. So I went to the US, I went to Purdue, really good school, got a PhD, I knew a lot, but I wanted to build things. And that's the first thing that I found out is that at universities back then, the idea of building things was not important. You know, you go learn that when you go to industry. We're not going to teach you how to build anything. And I went to ASU that was working on ASU Sat-1 at the same time that Bob was at Stanford with the first satellites. And I found the same thing that he did, that it takes years and years and years, and it never launches. And I also found out that I didn't know anything about building satellites. I had spent 10 years studying aerospace engineering. And when it came to building things, I was very, very bad. So there's something missing in the educational prospect. I moved to Cal Poly, which is a school that prides itself for learn by doing, and they don't have PhDs. They're really hands-on, and to start their space program. And the idea was like, okay, we're learn by doing. We want to do space. We need to build something. And my experience with the bigger student satellites was, no, that's too complicated. It's going to take too long, and it's not going to happen. And then Bob came to us and said, let's build something small. And that was very attractive, the idea of doing something simple, something small. The first initial project didn't work, but we stayed with it. And then the CubeSat standard came along as an idea of getting everybody together and trying to build all the satellites the same, which I think is one of the important reasons that this succeeded, is that Bob, from the beginning, there was a number of universities that they all wanted to build the same thing, and we all had the same problems. And that's very important because we didn't all solve all the problems, but the hive kind of figured it out when we worked all together, like the Borg. We worked very hard on the Peapod. That was one of the things that would really spend a lot of time on, developing the deployer system, which is also one of the things that I think helped CubeSat work, because it gave the rockets that were launching us a little bit of comfort that if something went wrong with the spacecraft, there was this big box that they would stay inside. And we call it a risk containment box. And then that let us go fly. So that was very interesting. We launched a few hundred satellites at Cal Poly with Peapods in everywhere, in most of the launches in the world. And at one point, NASA said, well, like, we cannot continue to give these contracts to a university. You know, there's an industry that's been created around CubeSats, and there's commercial activity, and there's this university as the key to all the launches. You know, you in the US, you cannot do that. So they say, we're going to have a commercial contract to do this next time. And then at Cal Poly, we started TIVAC in 2011 as a way of competing for those launches, and that's become Terran Orbital now, and it's doing all kinds of things. But that's an interesting part of the CubeSat story, that a lot of the CubeSat or small sat companies were startups that came out of the university teams that decided to start a company. And I don't know how CubeSat managed to do that, but there is a lot of students that when they finish a CubeSat project feel like they can start a company in space, which at the time when this started, nobody felt capable to start a private space company. I mean, the joke was that to make a small fortune in space business, you start with a big fortune, you know, and that was the way you do it. But nobody was doing that, and CubeSat really enabled that. The other thing that I think was very important is that as the needs grew, CubeSat adapted, and that kept us in the game even longer, which was very important for getting universal acceptance with we started with 1 use, we moved to 3 use, so people could do more, then 6 use and 12 use and 16 use. But the standard was still there. Anything that launches 12 use can launch 1 use, and that was a very important thing, that backwards compatibility. And then I want to go back to something that Bob said, because he's usually right, even though sometimes you think he's crazy, but he's not. And he said that the problem now is that we're moving away and we're getting more complicated, and we're getting more industrial, and that's kind of what's happening. And the thing that I wanted to put in the table, when we were starting to look for launches as a university, we were booking launches in Russia and trying to get contracts for launch. The big challenge was the people with the money, the NASAs, the Boeings, the NSFs, all those people were saying, this is too small. We cannot do anything useful. It's not worth our time to invest in this technology. And we had to do it on our own, which I think in retrospect, we can talk later, may have been a good thing, because nobody could shut us down by pulling our funding. But basically, that was the big thing, is they're too small. You cannot do anything. That was 1999, 2000. What's happening now? What's happening is all these startups that started with CubeSat are moving to bigger things because there's more performance and physics and all these things. But the same thing is the exact same sentence in 2024. These things are too small. You cannot do anything useful. And I've seen that movie before, and it didn't end the way people thought it was going to end. So I think we're watching the same thing. People really want to do big things, and that's okay. But they forget that there's a lot of things you can do with small satellites. And I think that's going to be important, especially, and I'm glad we've talked about interplanetary missions and really advanced things. It's a great way of testing the waters and trying things with low cost and making mistakes, because before you do it big. So this whole idea that they're too small and they cannot do anything, been there, done that. I got the T-shirt. I think it's going to be the same ending this time.